All right, welcome to 4.3b notes. This is for the Monday and Tuesday, October 16th and 17th, or actually 17th and 18th, somewhere right around there. I don't remember the exact dates. Today is the 14th, 15th. So Monday, October 17th, Tuesday, October 18th. Okay, let's get right into it. I have the absolute value of 5 plus 2n, and that's all inside the absolute value bars. And then I have it subtracted by minus 1, or subtracted by 1, and then it's equal to 6. Now if we remember, we have to move this minus 1 or this negative 1 to the other side before I can do anything with the absolute value, and before I can set it equal to the negative version of this. Because remember, absolute value, we have to do it twice. We have to do it to the regular, to the positive number. Remember, the original cannot have a negative. Absolute value cannot be equal to a negative in the original equation. And then I also have to do it to the negative version of it, because remember, inside the absolute value bars, I can have a positive and a negative solution in there for that variable. All right, so let's show the example of that. I would add 1 to both sides, leaving me absolute value of 5 plus 2n equals to 7. Now I know that I have to set this equal to also to the negative 7, because I'm going to solve for n, and I know that n could be both a positive and a negative, so I set it equal to the negative of that. Absolute value of 5 plus 2n just becomes 5 plus 2n when I'm solving for this, equals 7. Subtract 5 from both sides, gives me 2n equals 2. Divide by 2, n is equal to 1. So I know that n could be equal to 1. That's one of the solutions. And then I also need to find the second one. Well, that's 5 plus 2n equals to negative 7. I subtract 5 from both sides, leaving me 2n equals a negative 12. I divide by 2, n is going to be equal to a negative 6. So I know that my other solution could be n is equal to negative 6. And that should make sense, because if I plug the 1 in for n, 5 plus 2 times 1, or 2, so that's 5 plus 2 is 7. Absolute value of 7 is 7. 7 minus 1 is 6. Conversely, I have a negative 6 in for 2. That's 2 times negative 6 would be a negative 12. 5 plus a negative 12 is negative 7. But the absolute value of negative 7, as we know, is a positive 7. So that would be 7 minus 1, and that is equal to 6 as well. Okay? So that's why we do it to both. Moving on. Example 2 for you. I have a negative 7 times the absolute value of negative 4a plus 9 equals to a negative 119. And you might be thinking to yourself, wait a second, it's set equal to a negative 119. It is right now, but notice this negative 7 that is multiplied by the absolute value. Remember, I have to get rid of anything that's attached to an absolute value first. So if I divide this by negative 7 and do this by negative 7, then I'm left with the absolute value of negative 4a plus 9 equals to, well, negative 119 divided by a negative 7. Well, let's see, 119 divided by 7 is 17. So I know that a negative is a positive. So I know that it's set equal to a positive. So I'm not in a no solution opportunity here. The negative here was negative, but since I'm dividing my negative, it became a positive. Okay? So I also know that the negative 4a plus 9 is going to have to be equal to a negative 17 as well. Once I'm here, bring them out of the absolute value bars and solve away. Negative 9. So that's a negative 4a equals 17 minus 9 is 8. divide by 4, a is equal to -2. So I know that a is equal to -2. And conversely, -4a plus 9 equals a -17. Subtract by 9 gives me -4a equals a -26. Divide by 4, or -4, and divide by -4, a is going to be equal to, well, -26 over 4. You can leave it as 26 over 4, okay? I could reduce that, and if I reduced it, 26, 2 goes into 26, 13 times, 2 goes into 4, twice, and I have it reduced. Remember, I'm allowing you to leave it as 26 over 4 if you like. Just go ahead and make sure you can get it. Notice that a negative makes a positive. All right, example 3. We've got 7 of them today. So this is number 3. We have 7. Okay? I've got the absolute value of 7b plus 6 added to 7 of that, less than or equal to 69. So the first thing I have to do is I have to get rid of that 7. But notice that we have a less than or equal to up there, and we've got a graph. So we know we're going to have to graph this. Okay? We're going to have to graph this. So I have the absolute value of 7b plus 6 plus 7 less than or equal to 69. Now I know that if I subtract 7, which is my first step, then I'm going to have the absolute value of 7b plus 6 less than or equal to 62. Okay? Now, I'm right here. This is my absolute value inequality, right? And this is a less than. If you remember less than, what's the mnemonic that we think about? That it's probably going to be a and graph, which means they're going to go towards each other, right? I'm going to have a bookend, and going towards each other. It's going to be an and. But let's double check and let's find out for ourselves. I've got a 7b plus 6 is less than or equal to 62. So 7b plus 6 less than or equal to 62. I also have 7b plus 6. I need it to then negative 62, just like we do with the equal sign. But since it is an inequality and I have a negative across it, that means I have to flip the sign. So notice, I have flipped my inequality sign when I put a negative with 62. All right, let's solve. Subtract 6. 7b is less than or equal to, what is that, 56? And 7 divided by, so 56 divided by 7, less than or equal to, I do believe that is 8. Off the top of my head, let me double check. Yes, so b is less than or equal to 8. So b less than or equal to 8. Okay? And then I also have this one over here. Subtract 6. That's 7b greater than or equal to a negative 69, or 68, sorry, 68. A negative 62 minus 6 is the same thing as saying a negative 62 plus a negative 6. Remember, it means the same thing. So that's a negative 68. Divide by 7, b is greater than or equal to a negative 68 divided by 7. It's going to be a negative 9.7. 9.7. So as I look at this, and I want to graph this, let me put that other point up there for you. I look at this. I've got a less than 8 and a greater than negative 9.7. So I do have an and. I do have an and graph here. Let's do it. Less than or equal to 8. I am a closed circle at 8. Remember, the equal to bar underneath tells me it's a closed circle. right? Closed circle. And I'm going to be going this direction because I'm less than, right? And the other one is B is greater than or equal to a negative 9.7. So I'm going to be right here, just shy of 10. I am also going to be a closed circle because I have a less 2 bar, but I'm going to be greater than. So it's going to go this direction. Notice that my lines go together, right? Because this is an example of an and. I have this and this, and every value in between would make this inequality a true statement. All right. Moving to number 4. Moving to number 4. I have 6 minus the absolute value of negative 2n plus 6 less than or equal to negative 4. All right, so let's write this out. 6 minus absolute value of negative 2n plus 6 less than or equal to a negative 4. All right. Well, the first thing I see is I've got a 6 attached to it, right? And it's a positive 6, so I need to subtract 6 from both sides. So I'm now left with a negative absolute value of negative 2n plus 6 less than or equal to a negative 10. Negative 4 minus 6, same thing as saying negative 4 plus a negative 6, which is negative 10. And then I have something out here that's going to change things a little bit. I have a negative. And you're also thinking to yourself, wait, I got a negative out here. Well, this negative is really like saying I have a negative 1 in front of this absolute value, and I can't have that. I have to divide by a negative 1. Divide by negative 1. So what this gives me is the absolute value of negative 2n plus 6. Since I'm dividing by a negative 1, I got to flip my inequality, and a negative divided by a negative becomes a positive. 10 divided by 1 is 10. Now notice, I'm down to this, right? Do I have a negative out here anymore? I don't. This is as far down I can get before I have to start solving it, really. So I'm right here. So I don't have a no solution example here. I'm going to have some solutions. I'm going to have 2 of them. All right? So let's do this. I'm going to do them on either side. I have negative 2n plus 6 greater than or equal to 10. Subtract 6 from both sides. That's a negative 2n greater than or equal to 4. Divide by negative 2, divide by negative 2. N. This time it's going to be less than or equal to, because I had to flip my inequality because I'm dividing by a negative. 4 divided by negative 2 is negative 2. So I know that n is less than or equal to a negative 2. Remember, every time we multiply or divide across the inequality with a negative, I have to flip the inequality sign. All right, let's do it the other way. I have a negative 2n plus 6. This time I want the negative 10, so I have to flip my inequality sign so it's less than or equal to. I added a negative to the 10, so I have to flip the inequality sign. From here, subtract 6. This gives me a negative 2n less than or equal to a negative 16. Divide by negative 2, divide by negative 2. N is now greater than or equal to, divided by a negative, got to flip the inequality. 16 divided by 2 is 8. So I have n is greater than or equal to 8. So n less than or equal to negative 2. Close circle, since I have an equal to bar and I want to be less than. N greater than or equal to 8. Greater than. Equal to, close circle, going this direction. And you're going, well, wait a second. We started with an less than, so shouldn't it be an and? Well, remember, we had to do some work to it to get it to where we could go to solving it, right? And when we did that, we got down to here. that negative, when I divided by that negative that was out front, made it a greater than. So a greater than is going to be an example of an either or an or. Either or. All right. That was that one, so here we go. I have absolute value of a negative 10 plus 9x, all divided by 9, set to greater than 1. Well, I know that I have to get rid of the denominator first, right? I had to get rid of the denominator. And like when I was multiplying, I had to divide. This is being divided by 9, so I need to multiply both sides of the inequality by 9. What this is going to give me, once I multiply 9, the 9's on this side are going to cancel out. So I'm going to have absolute value of negative 10 plus 9x greater than 1 times 9 is 9. From here, I know that I have a negative 10 plus 9x greater than 9. And I also have negative 10 plus 9x negative 9. Since it's greater, I got to flip it. Becomes less than negative 9. Okay? So I'm doing it twice. Here we go. Add 10 to both sides. Add 10 to both sides. 9x greater than 19. Divide by 9. Divide by 9. X is greater than. And I'm going to give it to you in decimal form. 19 divided by 9 is 2.11. 2.11. The other one, solving for x, the second one, add 10. Add 10 gives me 9x less than 1. Divide by 9. Divide by 9. X is less than 1/9. In decimal form, that is going to be just 0.11. Alright, so I have x is greater than 2.11, and I have x is less than 0.11. Alright, so let's go to graph. So I look at this, and I want to be greater than 2.11, greater than 2.11. I am an open circle at 2.11. I made that circle nice and big so you can see that it was open. I'm going to be greater than. There's my arrows. And then I want to be less than 0.1. Well, 0.1 is not quite 0. It's definitely not towards 1. So it's going to be there, and it's an open circle, and I'm less than. Going this direction. Now notice that I stayed true to my original equation because I didn't have to divide or multiply by a negative across it. So my greater, or ended up being how I graphed it. Alright. Then you look at that for another second. Pause it if you need to. Always pause if you need to. We talk about this every time. Pause if you need it. Alright. Let's do a couple graphing of inequalities real quick. So we're going to discuss the solution to each system of inequalities. These are both in y equals mx plus b form, or what we call slope intercept form, which means I can graph them straight just by looking at them. I can graph just by looking at them because we are in y equals mx plus b, or what we call slope intercept form. The first one, well, let's go ahead and label them. I like to label. So I'm going to use this as line A. This one is line B. Okay? So A, line A. 3, which is my B term, that positive 3 up there is my B term, which is my y-intercept. and I am a greater than, so I'm an open circle at 3. My slope is a negative 2 over 3. Negative 2 over 3, which means going down 2 and over positively 3. Remember, a negative slope, I can only travel one way negatively. The other one has to be positive, because if I go down and to the left, which are both negative moves, that would make a positive slope. I could go up 2, but I have to go left 3, because that's my negative move. And then I can dash. Get my nice dash line. And remember, I'm a dash line on this one because it's just greater than. There's no equal to bar underneath. Okay? There's no equal to bar underneath, so I'm just a dash line. And I want to be greater than, so I'm going to shade above this. Well, the other one is y is less than or equal to x minus 2. So that tells me that I'm an equal to bar with my less than. So it's going to be a closed circle at negative 2. So closed circle, negative 2. My slope, it says x. Well, remember, what's out in front of x that we just don't write? Yes, it's a 1. And written as rise over run, that is 1 over 1. So up 1 over 1. Up 1 over 1. Up 1 over 1. You get the idea. 1 to 1. Down 1 over 1. Down 1 over 1. Okay? Get a nice straight line. And remember, I do all these points right now because I'm up here freehanding. So I want to make sure that I'm as accurate and as straight as possible. Alright? And this one is less than. So I would be shading down here. So I'm shading down here. And notice I'm shading down here, right? And the other one was greater than, so my line A was greater than. And it was greater than. Well, notice where I shade, where I have two colors. I have both the black and the blue in there. This area right in here, which I'm now going to shade in red because I want you to see it graphically. This is my solution to these inequalities. To this system of inequalities right here. That is my solution. Okay, to this system of inequalities. This down here was the solution to this one. This was the solution to that inequality. But this is the solution when I'm solving them together. All right, last example. I have 4x plus y less than or equal to negative 3 and 2x minus y greater than negative 3. Well, the first thing I notice is that they are in standard form. These inequalities are in standard form. And I can't graph in standard form. I need to switch them to y equals mx plus b. So I need them in y equals mx plus b. And I can do it pretty simply. I'm going to do the first one in blue. So I have 4x plus y less than or equal to negative 3. Remember, I want y by itself, the mx on the other side of the inequality, my number last. So I'm going to subtract this one by 4x. The reason I'm subtracting by 4x is this 4x is positive. So in order to move it to the other side of the inequality, I have to subtract it. But now they cross out on this side, leaving me just y less than or equal to a negative 4x minus 3. Okay? I want the 4x in front of the 3, which in this case is a negative 3, but I want it in front because I want it to look like y equals mx plus b. I can graph this right now. I have a negative 3, so that is my y-intercept. I am a less than or equal to, so I'm a closed circle. My slope is a negative 4, which means I am rise over run 4 over 1. In this case, I'm going to go up 4, 1, 2, 3, 4, but to the left 1. And the reason I didn't go down is that I would be off my graph if I went down and to the right. So I went up, okay? I can do one more, up 1, 2, 3, 4, over 1. So my graph is going to go in through this direction. I know it's a solid line because it has the equal to bar underneath. Try to get that as straight as I could. And I am going to be less than, which means I need to be below the line. Below the line. Okay? So I know that I'm going to end up shading down here. Alright. Let's do the second one. The second one. 2x minus y greater than -3. Well, I know that I need to move the x to the other side, which means I need to subtract by 2x, leaving me at -y greater than a -2x minus 3. Well, I'm not done yet. And I'm not done because it's a -y. I don't want -y, I want y. Okay? So I must divide by -1, must divide by -1, and I must divide by -1. Remember, if I divide across an equal sign or an inequality sign, I have to do it to every member, on both sides, right? So this becomes y. Since it's a greater than and a divided by a negative, it becomes a less than. I did that in green so you could see the difference. -2 divided by -1 is 2. -3 divided by -1 is +3. So I know that I can graph this now. I am a less than only, so I'm an open circle at 3. So open circle at 3. And my slope is 2, which is 2 over 1. So up 2 over 1, down 2 over 1. Okay? I think I have enough on there to get my nice dashed line. And there we go. And this one is less than, so I'm below the line again. So I'm going to show you below the line, below the line, below the line, right? All that's below. Remember, the first one is less than or equal to, so it's less than, so I'm below the line as well. Well, this is below the line, right? All this is below the line. Where I double shaded, once again, is my solution. So my solution is going to be right in here. And these values, these points on the graph, are my solution to this system of inequalities. In essence, these values right here are what makes my true statements for these inequalities. All right, hopefully you enjoyed this. Please behave for the substitute. Do your work. Be a good class. We'll see you on Wednesday/Thursday.